Hey guys, so we are going to be writing equations of exponential growth and exponential decay. When you are completely, totally finished, so basically you're going to start with a graph, a picture, and you're going to have to write the equation that matches. Remember that the equation that you're trying to get, again, whatever that function is, f of x, h of x, g of x, whatever you want to call it, okay? It's going to have these parameters. Remember, A is going to be a vertical stretch or compression. B is going to be the base. So if it's doubling every time, that's a growth. If it's halving every time, that would be a decay. But that's going to be raised to the x minus h. Remember, h is going to be that horizontal shift, either left or right. And then plus k. And remember, k is that vertical shift that goes up or down, okay? All right, so here's what we're going to do. We're going to use these two ideas, these two reference points. Remember, the reference points are coming from plugging in a 0 and plugging in a 1. And so if you plugged in a 0, anything to the 0 power is going to be 1. If you plugged in a 1, anything raised to the first power is just that same thing, okay? And so these reference points that we're going to use are just going to help us get those 2 points, okay? So what we're going to do is we're going to start with this first point, 0, 4. That is going to be our first reference point, and then 1, 6 is going to be the second point. By the way, how do you know which one to use? It's as you are climbing up the graph, okay? So in exponential growth, remember, every one of those are going to look like this. So as you're climbing up that graph, starting from that asymptote and climbing up, the first is the first point that you come to. The second one is the second point that you come to. Okay? All right. When we go to do this, every single time your asymptote is going to be k. So whatever your asymptote is listed at, that's automatically k. The rest of it, we're just going to use these points and plug and chug. So h equals 0. A plus k is going to equal 4. I know that k is 2, so a plus 2 is going to equal 4. That gives me a equaling 2. So far I have h and a. I'm looking for b and k. Let's do it again. H plus 1 equals 1. Still gives me an h equals 0, so that's good. It's a quick little check. And then we're going to go plug and chug into this. AB plus k equals 6. Remember, we found a to be 2, so 2b. K is 2, and 6. We do a little bit of algebra. 2b equals 4, b equals 2. Final answer, we're just going to plug everything in, okay? So when we go to write it, we write 2 times 2 to the x minus 0, and then plus 2. Okay, so this function becomes, this answer becomes 2 times 2 to the x minus 0, is the same thing as just x, and then plus k becomes plus 2. Keep in mind that you can't put these together because the order of operations, right? You're going to do exponents first. We're actually going to, this is kind of like a bonusy thing because you kind of can put them together. But. All right, let's do it again. Let's do a decay problem. So with a decay problem, your b should be less than 1. So it's going to be a fraction, and it's going to be less than 1. Okay? Same thing when you do a decay problem. Decays go in this direction, but you're going to go backwards and kind of climb the ladder a little bit. Okay? And use those points. So -1, -1 is our first point. And then -2, +1 is the second point. Remember that your asymptote is always k. Okay? And then here we go. We just do it. H equals -1. A plus k equals -1. I know that k is 2. So when I add 2 to both sides, I get a to equal +1. h minus 1 should equal negative 2. So let's just quick check, make sure we get the same h value. So when I add 1, I get a negative 1. Good. And then let's go do this one, right? So a over b plus k should equal 1. I know that a is 1, so we're looking at 1 over b plus negative 2 equals positive 1. So I'm going to add 2 to both sides. I get 1 over b equals 3, or 3 over 1. So 3b equals 1. b is equal to 1/3. Okay, I apologize for the shadows. Go to write your final answer. Your function is going to be a, which we found to be 1, times b, which is 1/3, to the x minus 1 becomes plus 1, right? Minus a negative 1. And then plus k, so minus 2. And for this one, you can get rid of that 1. And so 1/3 to the x plus 1 minus 2 works out pretty well. Okay? All right, so I wanted to show you a quick way to check your answer to make sure that it's correct. So remember with this first one, we had this exponential growth going through the points 0, 4, and 1, 6. So if I go into Desmos and graph it, here is the point 0, 4. Here is the point 1, 6. So at least I know I did it correctly. I typed in our equation that we got for an answer. Okay? Then I typed in the second one. Remember with the second problem, it went through the points -2, positive 1, and -1, negative 1. So when I go back into Desmos, here is the point, if I can get it on the exact number, there it is, -2, positive 1. And then the point, again, if I can get it on it, dun, 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 there it is, -1, negative 1. Okay? All right, last little trick. For those of you that want an extra little challenge, this was the equation for the first one, first example that I did for you. Okay, so here's our red graph. If I turn on the second graph that is a different equation, I get the same thing. Remember we had the point 0, 4 and then the point 1, 6. And notice it's the exact same graph. So 2 to the x plus 1 plus 2 is the same thing as, right, 2 times 2 to the x plus 1. So see if you can figure out why. Why is that the case? Why are those the same?